Hey there everyone, Mr. Schickert here. So I've got a question for you. What do we think is the relationship between the radius length of a circle, so the length of the radius, and then the weight of the circle? Do we think it's going to be linear, maybe proportional? Do we think it's going to be maybe exponential or logarithmic? Could it be trigonometric? Well, it just so happens that I've got this circle here. I've got a ruler, I've got a scale, I've got some scissors, and I've got a notebook. So let's find out together. So what I've done to start is I've drawn these different sized rings on my circle. And the first thing I'm going to do is use my ruler to measure the radius of the current circle. And then I'm going to mark that down in a table that I've created in my notebook. Then I'm going to take my circle and weigh it on my scale, and then record that weight in another column of that same table in my notebook. Once I've done all that, comes the fun part. Then I'm going to take my scissors and I'm going to cut into the circle kind of up to that next ring, get rid of that outside ring, and kind of create that new circle of a smaller size. I then will repeat all the same steps that I just did for the first one, getting the radius length and getting the weight, and keep going through all the circles that I have drawn on. Once I've got all that data collected, we're going to use Desmos to check out what the data looks like and answer some questions. Let's do it. So to start, okay, so now that we got our data, let's take our data and use Desmos to plot it into a graph. So once we're on Desmos, if you don't know how to add a table, you do the plus button and press table. And we've got X's and Y's. We want to think about what is going to be our X and what's going to be our Y between radius and weight. Well, the radius is independent. The radius length we just measure, that's independent of the weight, right? So that's going to be our independent variable, which is our X. So our radius will be our X, our weight will be our Y. And then I'll put in all the data from the video. I also took a few other points of data of measurements on my own, just to help make our data a little bit more robust to get a couple more points. So you'll see all of those in there as well. But as I enter these, you'll kind of start to see a function start taking shape. You saw on the video at once I got to 1.5, my table or my scale couldn't read the weight anymore, so I got a more accurate scale. It ended up being around 0.3 or so, and at 1 it was 0.1 or so. So if we zoom out a little bit, we see this is our this is kind of the function. So let's think about, what might make sense. What kind of function might be, what might our relationship be? Could it be, is it linear? Well, it's definitely not a line, so it's not going to be that. Could it be maybe like a trig function, trigonometric? Definitely not the sine function, because that's like oscillating. We could try something like, the log function. Oh, sorry, wrong place. That's going the wrong way. That kind of looks like the square root too, so that's not going to work. Well, what if we try like one of our, like a parabola or a cubic? Okay, parabola is kind of looking like it. It doesn't line up exactly right, but like maybe if we adjust kind of in front, like a coefficient. Well, that's the wrong way. What if we go like 0.3? Ooh, that's pretty close. Or 0.2. I like that. So it's not gonna be exactly lined up, but that looks pretty similar. And what we're gonna find is we have this this parabolic function. So the relationship between the radius length and the weight is going to be a parabola, and that makes sense because our weight of our circle is going to be based off of the area, right? So you guys remember that area of a circle is pi r squared, so it makes sense that it's an x squared type function because that r squared, the weight or the area, is based off of the radius squared. So let's now just really quickly think through just some other kind of general questions about now our function. Let's think about the x-intercept and the y-intercept. If we looked at our data, when we got x equals 0, what do we think y is going to be? Well, you can definitely tell as it's approaching it. It seems like it's approaching 0. Well, does that make sense? It's approaching the origin? Yeah, because if our radius goes to 0, if we end up having no circle at all, our weight's going to be 0 too. So our x-intercept and our y-intercept are both going to be the origin. What else? Let's think about our domain and our range. Our function, if we're thinking about it as a parabola, as an x squared, we can only think of it of our domain. The x can only be bigger than 0, right? Because we can't have a negative radius. Same thing with our weight. We can't have a negative weight. That's only positive numbers exist for that. So that also has to be above 0. So we'd say our domain and our range are both, which like domain is x is greater than 0, and our range is going to be y is greater than 0. Yeah, I think that's good. And so this is the kind of stuff that, statisticians, mathematicians, doctors, engineers, actually basically every profession out there, marketing and business do this a lot. We'll do this kind of curve fitting or this analysis of functions to really think about, okay, we have this data. What kinds of things might model this data? So now in this chapter, we're going to talk a lot more about parabolas and this x squared function.